Hello all, if you are a designer of LED based circuits, LED based lighting circuits, or any simple boards with an LED, or if you have Arduino R4 Wi-Fi board that is shown here, um, then you must be knowing of a technique called charlie-plexing technique. So what is this technique? Basically, if you see here, the LEDs on Arduino R4 Wi-Fi are connected in a array form, right? So what actually are we doing here is, here if you see, they are of 12 into 8 matrix, and eh, basically that means there are 96 LEDs in total here, right? Generally, if you connect or if you control each LED, then that means you need 96 pins. But these LEDs can be connected, should be or must be controlled by as low pin count as possible, right? That's the intention, so that you don't waste most of your GPIOs. So that's where this charlie-plexing technique comes into picture. Let us look at what is this technique. Let us discuss about the charlie-plexing technique. Okay, now let us assume after connecting the various interfaces on your chip, you come to estimation that you have 6 pins available to control the LEDs. So using a charlie-plexing technique, if there are n number of pins, the formula is n square minus n. These are the number of LEDs that can be controlled using charlie-plexing technique. So what this means is, if n is equal to 6, 6 square minus n minus 6, sorry, which means 30 LEDs can be connected, right? So using 6 pins, you can connect 30 LEDs, which is a very biggest advantage, right? So considering this, now, if you take Arduino R4 Wi-Fi 6 board, considering that you have 96 LEDs, let us see from the schematic of the Arduino R4 Wi-Fi, how many pins are used. Okay, so this is a Arduino R4 Wi-Fi 6 LED matrix schematic. So this is from the Arduino website. So basically, if you see here, this is the LED matrix. Okay, and you can see each LED has a particular number. Like that means there are 12 cross 8 matrix arrangement present on the board, right? That means 96 LEDs. So using the charlie-plexing technique, if you do n as 10, for example, let us assume 10 pins are available. So n square minus n, which is 10 square minus 10, which is 100, 100 minus 10, 90. So you can only control 90 LEDs, right? That means you need 11 pins. 11 is like 11 square, 121 minus 11, which will come to 110. So using 11 pins, we can control up to 110 LEDs, whereas we have 96, which is okay. So that means you need a total of 11 pins. So if you see the schematic, you see that it started from 0 to 10. That means 11 pins are used. So if we go to the schematic further, you can see the LED matrix is using total of 11 pins. So hierarchical block is added here actually. So that means what a big advantage, right? Using just 11 pins, okay, on the of the microcontroller, you are controlling 96. So that is the biggest advantage of charlie-plexing. Now, there are other disadvantages associated with it as well, but the advantages outweigh the disadvantage here. Now, the next question comes, how do we achieve the connectivity? Yes, formula is simple and we are saying advantages, but how do we achieve that? So, this is a simple representation where using pins, we are controlling 6 LEDs here. So, if you can see here, a simple way of connecting the LEDs when using the charlie-plexing technique is presented here. Like for example, when you set x1 as high and X2 as low, so the LED 1 glows. Okay, and if you want LED 5 as well at the same time, X3 also had to be made ground. So similarly, you can use your techniques based on your requirement, connect the LEDs and use them accordingly. So a very good technique, right?